6.6 Cartesian vectors in R2. Let us suppose vector AB is any vector on the plane with endpoints A and B. So here we have endpoints A and B. So we can say that vector AB is a Cartesian vector because its endpoints can be defined using Cartesian coordinates. So that means that if points A and B have Cartesian coordinates, that means we can also call a vector AB as a Cartesian vector. So if you want to translate vector AB so that its tail will be at the origin, we can call that as the position vector OP with coordinates of A and B. And the magnitude can also be easily calculated using the Pythagorean theorem. So in this case, if we want to move from point A to point B, the x value, we will have to translate or move 3 units to the right. So if we start from the origin, 3 units to the right will be somewhere here. And for the y value, we need to move 4 units up. So again, from the origin, 4 units up would be over here. So now we can just simply draw our position vector to a point here. We can call it point P with coordinates A and B. Now if you want to find vector OP, it will just simply be 3 and 4. Now, how do we find the position vector without doing all of this manually? Well, we can just simply use point B and minus point A. Now, you must remember that the order is important. We cannot take point A and subtract it with point B because then the answer will be wrong. So in this case, point B would be minus 1 minus negative 4, and the x value would be 2 minus negative 2. So we will get an answer which is 3, 4. So in general terms, we can find the position vector of AB by subtracting the second x coordinate with the first x coordinate and the second y coordinate with the first y coordinate. And now the magnitude. To find magnitude, we simply just find the square root of the sum of squares. So the square root of the square of the x coordinate and the square of the y coordinate. So it will be 3 square plus 4 square and square root. So 3 square plus 4 square will be 25, and root 25 will be just 5. So the length of vector AB will have a length of 5 units. Now the next thing that we're going to learn is the standard basis vectors. Now this is just actually very simple because we're just talking about the unit vectors which has a magnitude of 1. So when we talk about vector I is over here on the x-axis because it has the coordinate x of 1 and y coordinate of 0. So this will just be vector I, and vector J is the same. It will be just on the y-axis with just 1 unit in length. So vector J. So when we're talking about standard basis vectors and unit vectors, they're basically talking about the same thing. So let's say we want to find 3 vector i's. So 3 vector i's will be just over here, 3 vector i's, and 2 vector j's will be just right here, 2 vector j's. So the coordinate would be just 3, 2, or the position vector would also be 3, 2. So let's say we are given vector OA which has coordinates of 5 and negative 7. Now for vector OA, we already assume it is a position vector because when it starts from O to point A. If it starts from O, it means it's starting from the origin. So vector OA is a position vector. So to write it as the standard basis vectors, all we have to do is very simple. We just put 5 vector i's minus 7 vector j's. And conversely, if we are given vector OB is 3 vector i's minus 6 vector j's, then the coordinate, or the point would just be 3 and -6. Very simple, right? Next, so when we want to talk about adding position vectors, so if we want to find vector OC, all we have to do is just basically add vector OA and vector OC. So we just have to add the x coordinates together and the y coordinates together. Very simple. Next, so if we have OP here with coordinates of A and B, and we want to find two OPs, all we have to do is just multiply the scalar multiple with the coordinates, with the x coordinate and the y coordinate. So if we want to find 2 OP, all we just have to do is multiply A with 2 and B with 2. The same goes if we want to find negative OP. All we have to do is just multiply A by -1 and B by -1 also. Now, let us do a question here. If vector x equals 2 vector i's minus 3 vector j's, and vector y equals -4 vector i's minus 3 vector j's, what is vector x plus vector y, and what is the magnitude? So all we have to do here is just sub in the vectors into the equation and to just add and subtract all of it together. So 2 vector i's minus 3 vector j's minus 4 vector i's minus 3 vector j's. We will get -2 vector i's minus 6 vector j's. That's it. And if we want to find the magnitude, all we just have to do is we have to square root, and we have to square the x coordinate and the y coordinate. So it would be -2 squared plus -6 squared, which we will get an answer of square root 40. Yeah, and that's it. That's it for 6.6. Thank you.